because it's normally instinctual. Let's go! Got it! Let's go!
Jason just threw an interception in Madden. It's not the first time this has happened because he's bad at the game. Now, his reaction immediately is to drop his controller on his bed in fury. So he just walked over from his chair, he's getting ready to drop it. So there's potential energy stored here in the controller. And potential energy can be represented by the formula PE equals mgh. The m being the mass, the g being gravity, and the h being the height. So let's say Jason is getting ready to drop a controller with a mass of 100 grams at a height of 1 meter. And of course, for gravity, it would be negative 9.8 meters per second squared.
Now let's take a quick pause here and talk about some math, because who doesn't love math? I know I do. So, as we know from the formula, PE equals mgh, we have our mass, which is 1 kilogram or 100 grams. We have our height, 1 meter, and of course gravity always stays the same. So with this being said, the amount of potential energy that is stored in the controller at this current time is going to be 9.8 joules, because that is the unit for potential energy.
Now, once Jason drops this controller, kinetic energy will happen in the controller as it falls onto the bed.
I'm back with some more math. So first off, when an object is in free fall, it's exerting kinetic energy. The kinetic energy formula is Ke, kinetic energy, equals mass 1, or mass of the object, times the velocity squared, multiplied by 1/2. What's the velocity? Looks like we're back to kinematics. Seeing as the object is in free fall, we know that its acceleration is negative 9.8 meters per second squared. We also know that the initial velocity of this object is, well, 0, because of that split second right as it gets dropped, there is no velocity. And because we see that it takes roughly 0.8 seconds for the object to reach the ground, we can then use the formula Vf equals Vi plus A times T to find the final velocity. And with that final velocity, we can plug that back into the kinetic energy equation to find the amount of kinetic energy exerted when the object is falling.
Hi.
Work occurs when a force caused by an object exerts a force and displacement on another object. For example, Pat, the center here, who snapped the ball to Jake, got absolutely obliterated when I bull rushed him. I exerted a force and caused work on Pat. The force must be done parallel to the displacement of an object for work to be done. Work gives an object the ability to produce change in itself and objects around it.
Hey, so, what can that term be simplified into?
Well, basically, work gives an object energy.
Damn, dude, he stopped your car. You're gonna have to do something about that.
Because I need more power because my work is not being exerted at a fast enough rate because Jason is not letting me through.
Jake wanted this to be in the video, so it's him throwing a football into the net. So after 12 attempts, there it is.
Right down the middle.
Now, Jason, what do you have to say about this?
You know, if I could stop a car, I sure deserve, a starting spot on that football team. If I could stop a car, just imagine what I could do to the defensive end.
That's not someone named Joe DeCroce.